All right, so let's start the next section here. Trying to get my camera to stop wobbling. Okay, chapter 4. If you thought all the sections before this were easy, great. I'm very happy for you. This is going to be completely different. So chapter 4, chapter 5, we're going to get into some stuff that's not, I wouldn't say, well, it is difficult, but I'm not going to say that it is more difficult than the stuff that you've done before. It's just completely different. So what are we going to do? So we want to sketch a graph that looks like this. That's not too bad. We also want to sketch the reciprocal of this. By reciprocal, I mean what is f to the power of -1 of this function. So the f of the -1 of this function is 1 over x. Or if I'm talking about what is the inverse of this function here, f to the -1 of x, meaning an inverse function of this, is 1 over x plus 3. This is what I mean by inverse. You just flip that original function. So this is going to be a little bit tricky, but it's not too bad. And I'm going to show you exactly how to do this. And I've got the procedure here. I'm going to keep jumping back and forth. I'm sorry I can't show you the whole thing all at once, but this is what we're going to do. So, procedure. First thing we want to do is plot the original function. Or plot the original graph. It's going to be easy to write. So let's plot the original graph. In this case, my original graph is y equals x. I'm going to assume you know how to do plot a linear line. If you don't, that's an issue. You should know how to do this. So y equals x is pretty easy. It has a slope of 1, and it has a y-intercept of 0. So here's my line. Arrows, always put arrows. Original graph plotted, not too bad. Next, number 2, we need to find the vertical asymptote. If you don't know what a vertical asymptote is, it's a point on the graph, or a line on the graph, where my graph is going to approach that line but never touch. I'll show you what that means in a sec here. So in our case, the vertical asymptote is the value that is not allowed in this function, the non-permissible value. So in this case, x cannot equal 0. So I need to do a vertical asymptote here at x equals 0. So here's x equals 0. You can't really see that. I'll do it slightly beside so you can see this vertical asymptote. So a dotted line here. Sorry, there's a fly that keeps going in my face as I'm trying to record this. So if you hear that, I apologize. So here's the vertical asymptote. Next, what I'm going to do, the third thing here, is I'm going to use a table of values to plot points on either side of the vertical asymptote. And in order to do that, we're going to see what this shape of my graph is. So we're going to do this until we find a pattern. So eventually, you will probably be able to look at a graph like this, draw the original, draw the asymptote, and draw what the reciprocal function looks like. But for now, you're probably not going to be able to do that. So eventually we're going to figure this out. So the definition of a vertical asymptote means that I'm going to have my line either really approaching this line or approaching down here? We're going to take a look at that. So let's make some points here. So notice my vertical asymptote is at 0. So let's pick some numbers to the left of that and to the right. So I'm going to do a set of coordinates like this. Let's pick 1, 2, 3. That's going to do on the right-hand side. And let's pick some on the left. So -1, -2, -3. And plug them into my original function. Remember, my original function for this is 1 over x. So 1 over 1 is just 1. Then I've got 1 over 2. Then I've got 1 over 3. And if I do this over here, I've got -1, -1 over 2, -1 over 3. So this is what my graph looks like, or these are the points that I'm dealing with here. So I'm going to plot these on the graph, and we're going to try and see if I can connect the dots and see what it looks like. So I've got a point at 1, 1. I've got a point at 2 1/2, 2 1/2, 3 1/3. So I got some points like that. On the other side, I've got -1, -1, -2, -1/2, -3, -1/3. So you might not be able to recognize a pattern with that. However, knowing our vertical asymptote, we're going to have a line that goes through these dots and approach the line but never actually touch. That's the definition of an asymptote. And this is going to keep going backwards this way and also never actually touch the y = 0. So if you think about it, what number do you plug into for x here to make this equal to 0? There's no number that makes that work. So we've got two asymptotes. Look at the same here. My line, or my curve, is going to approach the asymptote, approach x = 0, but never actually touch. So this is what our graph looks like. You've got a curved line here, a curved line here. Notice these curved lines are sandwiched between asymptotes. Asymptote here, asymptote here. So that's going to be our kind of method that we are going to use for this. Let's try another example. Here's our equation and the inverse. Let's first draw the original equation. So my slope here is 1. The y-intercept is 3. So here's my y-intercept, up 1 over 1, up 1 over 1, same in the reverse direction. So we get a line that looks like this. Oops, that was probably loud for you. Here's that. Plot out my vertical asymptote. So at what point does this equal 0? Maybe you've noticed by now a little bit of a pattern as to where the asymptote is. Did anyone notice that yet? It's simply at my x-intercept. My x-intercept was here, that's where the asymptote is. Same for this one. X-intercept was at 0, that's where my asymptote is. So wherever my original, whatever's in the bottom in the denominator, whenever that touches 0, that's where you've got an asymptote. Just as a easy point with that. So then I want to do a table of values. So you'd put in a table of values and you try and figure out what's the pattern that this looks like. However, I'm going to show you a shortcut because everybody loves a good shortcut. Notice where my points are, where my graph is on either side. So I've got here a point here. I've got a point here. That is going to be a point on my inverse. And I need to be sandwiched kind of in between these lines. So I know my graph is going to look something like this. I know a bunch of you right now are thinking, Mister, I have no idea what the heck he just did. And that's okay. If you don't see this pattern, because you're going to have a weird kind of shape like this on either side of the asymptote. You just need to look at which corner is it going to be. Is it going to be here? Is it going to be here? Is the curved part here? Is the curved part here? Just look at your original graph. My original graph is in this kind of quadrant, so it's curved here. My original graph is in this kind of quadrant, I curve it here. That's the shortcut you can do. If you don't want the shortcut, just go back to what I showed you for the other one. So put in your x values and your y values on either side of the intercept here. So x is -1, or -1, -2, and 0. 0, -1, -2, and -4, 5, 6. And plug those in the graph and see what you would get from that. But it'll give you this pattern. So either way, whichever one you're most comfortable with, that is what you would do for this to actually plot that out. Let's try one that is a little bit more complicated. And by a little bit more complicated, I mean a quadratic function. So we have this as my original graph, and I want to graph the reciprocal of that. So the reciprocal, after the -1 of x, is going to be 1 over this x squared minus 4. Now, we can factor that on the bottom, actually. I get 1 over x minus 2, x plus 2. Oh, you can't even see that. So I can factor it to look like this. This is my reciprocal function. Now, if I look at this, any cases where I've got some sort of asymptote with this would be when the denominator equals 0. So in this case, x cannot equal 2 or -2. So even without graphing the original function, I know where my asymptotes are. But let's just double check this. So we can graph the original, x squared minus 4. So this is just an easy case. My y-intercept is at -1, 2, 3, 4. Let's go out 1, up 1, out 1, up 3, out 1, up 1, 2, 3, 4, 5. Do the same on the other side. And here's my original graph. Nice quadratic function that looks like this. Now I want to put in the asymptotes. I've got 2 of them. X equals 2 and -2. And surprise, surprise, they're at my x-intercepts, just like I promised you they were going to be. So let's draw those in. And once I've drawn this in, my strategy to figure out where this inverse function is going to be very similar. So I need to try and figure out, what is my graph going to do on this side? What is my graph going to do in the middle of these 2 asymptotes? And what is my graph going to do on the right-hand side? Again, 2 methods. Either do a table of values and pick some points in the middle, and on the left and on the right, see what the pattern looks like, and then plot it. Or what you're going to do is just recognize you can tell what's going to happen here. Notice whichever quadrant I'm in. Now I've got 6 quadrants. I'm sandwiched here between 0 and the asymptote. So there's a quadrant. Here's a quadrant. Between 0 and these 2 asymptotes is a little box. Here's a little box. Here's a box. Here's a box. So I need to figure out which of these I'm going to be in. And I can tell you right now, my original graph is in this quadrant, and this quadrant. So that's what my graph is going to be like. So even without needing to look at this, I'll do it with a pencil. I don't know if you'll be able to see the difference, but I'll try it. So you're going to have a function that's in here. You're going to have a function that's in here. And you're going to have some function down here. Confused? I'm guessing so. I'm going to double check this with a table of values. I'm going to prove that this actually works. So let's pick some values here. So this is negative 1, 2, 3, and 4. So negative 4, negative 3, that will give me something out here. Let's pick negative 1, 0, and 1 to go in the middle region. And on the right, let's do 3, 4. Let's plug in values. So again, put that in your original function. Here's what you're gonna get. So these are all the functions you're gonna get. So negative 4, so negative 1, 2, 3, 4. Is that some decimal? Yep, got that. This is at some, oh, I did a little bit too high. It should be more down here. But I'm in the right quadrant. And then same with this. Yep, right quadrant, white quadrant. So this is how you're going to do something like that. Again, if you didn't recognize, looking at, okay, my original function goes into this spot here, that's sandwiched between the two asymptotes, so I'm gonna put the curved line there. If that part didn't make sense, do a table of values. The table of values will always tell you where you're gonna be. You just need to make sure that you're doing some in each section of the asymptote. So something to the left of this asymptote, something in between, something to the right, so you can double check. But your patterns for this are always gonna look the same. So for quadratics, you're always gonna have this kind of a shape. Or if it's opening down, you just do the reflection of this. So you're gonna see some very similar traits with that. Nothing too tricky with it. If you need, again, I can go through some of these in class, show you what they look like, but you will need to do this. This is coming on the test, and you need to understand chapter 4 before you can do chapter 5. So please make sure that you fully understand this before moving on to the next section, because we're gonna build on top of that. So that is chapter 4, and I will see you in class.